Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P154D indicates a low voltage condition at the Engine Control Module (ECM) during the automatic restart process. This DTC is crucial for understanding potential issues affecting the engine's automatic stop-start functionality, particularly relevant in Honda Accord models produced between 2017 and 2023. The Powertrain Control Module, PCM, monitors various parameters, including the battery voltage level, as part of its comprehensive engine management duties. A low voltage situation can affect the performance of the engine, causing issues during idle stop operations. Identifying this DTC helps ensure that both the battery condition and charging system are functioning correctly. Proper troubleshooting steps must be followed to isolate the problem and determine if it stems from the battery, wiring, or the PCM itself. The DTC P154D suggests that the Powertrain Control Module, PCM, has detected a low voltage condition during the automatic restart of the engine. The PCM, often referred to as the Engine Control Unit, plays a vital role in managing engine operations and makes precise adjustments to optimize performance and fuel efficiency. Commonly located near the engine bay, the PCM relies on stable voltage levels to function properly. If the voltage drops too low, it can impair the PCM's ability to manage critical functions like fuel injection and ignition timing. Components such as the 12-volt battery and alternator directly influence the voltage levels detected by the PCM. Understanding the operational role of the PCM and associated components, like the battery, is fundamental to accurately diagnosing issues related to this DTC. Several factors may lead to the activation of DTC P154D. A weak or failing 12-volt battery is the most common culprit. It may not hold a charge effectively, impacting the voltage supplied to the PCM. Corrosion or looseness at battery terminals can create resistance, resulting in inadequate voltage reaching the PCM. Additionally, aftermarket installations connected to the battery could draw unnecessary power or introduce faults, affecting overall system voltage. Reviewing these potential causes is essential for an accurate diagnosis. Each of these factors not only influences the function of the PCM, but may also lead to further electrical issues within the vehicle. Understanding the relationship between systemic components is key to resolving DTC P154D. Diagnosing DTC P154D also involves recognizing symptoms indicating a potential issue with the battery voltage during engine auto restart. One primary symptom is the failure of the engine to restart automatically. This can signify that the PCM is unable to receive adequate voltage for operation. Additionally, there might be noticeable performance issues such as rough idling or hesitations during acceleration due to insufficient power management. Drivers may also experience problems with the auto idle stop feature, which may not function as intended. These symptoms can significantly affect driving experience and overall vehicle efficiency. Awareness of these signs allows for timely diagnostics and repairs, preventing further complications. The first step in troubleshooting DTC P154D is to ensure the vehicle is turned to the on mode, which activates the electrical systems without starting the engine. Following this, the diagnostic system, HDS, should be used to clear the DTC from the system memory. This step is critical for verifying if the DTC reoccurs after clearing it. Once cleared, the engine should be started and maintained at 3,000 revolutions per minute, RPM, in either P, park, reset, or demo run, or N, neutral, until the radiator fan activates, followed by idling the vehicle. This process helps replicate the conditions under which the DTC was set. It's essential to repeat these steps several times to confirm whether the issue persists. This systematic approach lays the groundwork for isolating specific faults related to voltage concerns during the automatic restart. In this troubleshooting step, it is essential to utilize the HDS to check for both pending and confirmed DTCs. The presence of DTC P154D indicates a need for further investigation, confirming that the failure has been duplicated. If the DTC appears as confirmed, it verifies that the issue is not intermittent and is current. However, if there is no DTC active, this suggests that the system is functioning correctly at that moment. In such cases, reviewing the vehicle's battery connections and the battery's overall condition is critical. Additionally, if an onboard snapshot has been recorded, it is beneficial to attempt to reproduce the failure using the same conditions observed during the snapshot. This step is pivotal in distinguishing between chronic issues and temporary malfunctions, enabling accurate diagnostics. The next step is to determine if any related DTCs such as P0562, P065A, and P16BB are indicated alongside P154D. Each of these DTCs points to specific issues within the charging system. For instance, DTC P0562 indicates a low voltage in the charging system, while DTC P065A points to a malfunction in the alternator. P16BB indicates a low voltage condition in the alternator terminal circuit. Identifying and addressing these associated DTCs is vital, as they can complicate or exacerbate the primary issue indicated by P154D. If any of these DTCs appear, it is critical to follow their respective troubleshooting protocols. Ignoring underlying DTCs can lead to incomplete repair and potential reoccurrence of the symptoms. Comprehensive diagnostics of the vehicle's electrical charging system is essential in maintaining the vehicle's operational integrity. In this troubleshooting step, the focus shifts to the 12-volt battery itself, which is critical for supplying voltage to the PCM. Testing the battery condition will help determine if it is holding a charge effectively. Consider checking the specifications of the battery to ensure it matches the vehicle's requirements. An incorrect size can lead to performance issues. Furthermore, inspecting the battery terminals for corrosion or looseness is vital, as this can cause poor electrical connections. Corroded terminals can significantly impede the flow of current, which may trigger DTC P154D. Ensuring that the battery connections are tight and free from corrosion will help establish a robust electrical pathway. This step emphasizes the importance of the battery as a central component in the electrical system of the vehicle. The final troubleshooting step involves a thorough inspection of any aftermarket parts connected directly to the 12-volt battery terminals. Aftermarket components can unexpectedly draw power or introduce faults into the system, thus influencing voltage levels and potentially triggering DTC P154D. Checking the connections for reliability helps ensure that all components are functioning optimally without retarding the battery's performance. Identifying any potential issues with these aftermarket installations is critical to prevent further complications. This step rounds off the troubleshooting process, connecting the diagnosis to a broader view of the vehicle's electrical ecosystem. A careful examination of these elements helps in achieving both short-term repairs and long-term reliability. After completing the necessary repairs and adjustments related to DTC P154D, it's essential to conduct a final verification of the repairs performed. This involves clearing the DTC using the HDS and subsequently retesting the system to ensure the code does not reappear. Monitoring the performance of the vehicle post-repair allows for confirmation that the issues have been effectively addressed. It's vital to keep an eye out for any reoccurring symptoms that might indicate unresolved problems. This final step is crucial for guaranteeing customer satisfaction, ensuring the vehicle's performance is restored to optimal levels. Always provide documentation of the repairs and verification process to ensure transparency and build trust with clients. Preventive maintenance is key to avoiding the onset of DTC P154D and similar electrical issues in the future. Regular checks of the 12-volt battery ensure it is in good working condition, capable of delivering necessary voltage levels. Additionally, periodic inspections of battery connections help to identify any corrosion or loose terminals before they become problematic. Keeping track of voltage levels across your vehicle's electrical system provides insights into performance and potential impending failures. By proactively monitoring these areas, vehicle owners can mitigate the risk of experiencing DTCs related to low-voltage incidents. Preventive maintenance thus plays a crucial role in enhancing the longevity and reliability of the vehicle's electrical system. In conclusion, identifying and addressing DTC P154D is essential for maintaining the performance of the Honda Accord models from 2017 to 2023. Understanding the roles of critical components, such as the PCM and battery, is crucial for troubleshooting. Clear diagnostic processes help in isolating the problem, whether it is a failing battery, loose connections, or other related DTCs. Proper repair and verification steps ensure that the issue does not persist. Moreover, implementing preventive maintenance strategies can further enhance the reliability and longevity of vehicle systems. By acknowledging the factors surrounding DTC P154D, both technicians and vehicle owners can work together towards ensuring peak performance and dependability. Please like and subscribe to the channel. See you next time.